It is late, and you have arrived here. Whether your day was kind or difficult, this hour is yours to rest. Let the small worries that climb into the dark slip back beneath the surface. Tonight we will drift very slowly into the deep, slow story of the Earth itself, a planet that has been quietly turning and changing for more than 4.5 billion years. This is the Circadian Institute, a place for slow stories at the edge of sleep. We do not raise our voice. We do not ask anything of you. We simply travel together somewhere quiet until rest finds you. Tonight we are visiting the deep, slow story of the ancient Earth, a world of fire that cooled into stone, the first oceans falling as endless warm rain, the long, quiet age of microbes, continents drifting and gathering and drifting apart again, ice reaching the equator and slowly melting, all unfolding across spans of time so vast they can only be approached gently. Subscribing helps these nightly journeys keep going. Let your body settle. Feel the weight of yourself held by the bed beneath you. There is nothing you need to do tonight, and nothing you need to remember. The Earth has been turning quietly for more than 4.5 billion years, and tonight is simply one more calm moment held inside that vast, patient story. Tonight we drift slowly through the deep history of the planet itself, a glowing young world cooling under a sky of cloud, the first rain falling for ages into the first seas, continents wandering across the face of the Earth, ice advancing and retreating in long, slow rhythms, toward a kind of patience measured not in years but in hundreds of millions of years. The journey is slow on purpose. No part of this story asks you to stay awake for it. If you fall asleep before we reach the end, that is exactly the right ending. Let the bed hold you, let your breath slow, and let the patient story of the ancient Earth begin. To begin tonight's journey, we have to learn to think in a very slow way. The story of the Earth is not measured in days or years or even centuries. It is measured in millions and billions of years, spans of time so long that the ordinary mind cannot really hold them. We will not try to grasp them all at once. We will simply walk into them slowly, the way you might walk into a deep, quiet forest. The Earth is about 4.5 billion years old. To be more precise, the best measurements place its age at roughly 4.54 billion years. That number is so large that simply saying it does little. A billion is 1,000 million. 4.5 billion years is a stretch of time longer than anything our species has ever directly experienced, and yet the whole of it belongs to the planet's quiet biography. One gentle way to feel this scale is to imagine the whole history of the Earth pressed into a single year. On that calendar, the planet forms at the first moment of January. The oceans appear in late February. For month after month after month, almost nothing happens but the slow, quiet work of microbes in the sea. The patience of it is almost beyond imagining. On that same compressed calendar, the first complex animals do not appear until the middle of November. The great forests come in early December. The age of the dinosaurs fills the middle of that last month and ends in the night of the 26th. The entire history of recorded human civilization occupies only the final few seconds before midnight on the 31st of December. This is the most important thing to carry gently into tonight's journey. For almost all of the Earth's history, there were no people, no animals, no forests, only rock and water and sky and the slow, patient chemistry of a world becoming itself. The story is not mostly about us. We arrive only in the final breath of it. The rest is the long, quiet life of the planet alone. How can anyone possibly know the age of a planet? The answer lies hidden inside the rocks themselves. Certain minerals contain tiny amounts of radioactive elements, and those elements decay into other elements at a fixed, unchanging rate. By measuring how much has decayed, geologists can read the age of a rock, the way one might read the rings of an ancient tree, only far more slowly and far further back. The oldest mineral grains ever found on Earth are tiny crystals of zircon from the Jack Hills of Western Australia. They are about 4.4 billion years old, older than almost any surviving rock. They are far too small to see without help, and yet each one is a quiet messenger from the planet's first 100 million years, carried unbroken across an unimaginable depth of time. The Earth did not form alone. It was born together with the Sun and the other planets, out of the same vast, slow cloud of gas and dust. To begin the planet's story properly, we have to step back even further, to a time before the Earth was a world at all, when it was only a faint thickening in a quiet disk of dust drifting around a young star. There is something restful in this perspective. The worries of any single night are very small, held against 4.5 billion years of patient planetary time. The rocks were here long before us and will remain long after. Tonight you are simply resting for a while on the calm surface of a very old and very patient world. So let the scale of it settle over you gently. The way dusk settles over a quiet valley, there is no need to hold the numbers. There is no need to follow every step. The story will move at the speed of deep time, slow, unhurried, and patient, and you are welcome to drift off into it at any point along the way. Geologists have given the great stretches of this history gentle names like chapters in a very long book. The earliest is the Hadean, the Age of Fire. Then comes the Archean, the Long Age of Microbes. Then the Proterozoic, the age of slowly rising air and gathering complexity. And only the last small part, the Phanerozoic, is the age of visible life, the seas full of creatures, the green land, and finally ourselves. We will move slowly through these named ages tonight, and you do not need to remember any of them. The order of that book is written into the rock by a very simple, very patient rule. Layer upon layer, sediment settles and hardens, and each new layer rests gently upon the one before it. So in an undisturbed cliff, the deepest rock is the oldest and the highest is the youngest. Reading downward is reading backward in time, slowly through age after age, the way one might turn back through the pages of a long, quiet history. But the record is not complete, and that is part of its gentleness. Most of whatever lived left no trace at all. Most rock is eventually worn away or folded back into the earth. What survives is only a scattered, quiet handful of pages from an immense book. And yet from those few patient pages, the whole long story can still be slowly and carefully read. Let us begin then at the true beginning, not with the earth itself, but with the great quiet cloud from which the earth and everything on it slowly came to be. Before the Earth, there was a cloud. About 4.5 billion years ago, in this quiet corner of the galaxy, there was an enormous slow cloud of gas and dust, cold and dark and immense. It drifted in space for a very long time, doing almost nothing, simply existing in the deep quiet between the stars. Everything that would one day become the Earth was already there, scattered thinly through that patient darkness. Then, very slowly, the cloud began to gather itself. Perhaps the gentle shock of a distant exploding star nudged it. Under its own faint gravity, the cloud began to draw inward, growing slowly denser at its center over a span of time longer than any human history. There was no sudden moment. There was only the slow, patient pull of gravity, working without hurry across the dark. As the center of the cloud grew denser, it grew warmer until at last it became a young star, our sun, newly lit and quietly fierce. Around the new star, the leftover gas and dust flattened into a vast, slowly turning disk. Everything that would become the planets was in that disk, drifting in slow circles, waiting to be gathered into worlds. Within the turning disk, tiny grains of dust began to touch and stick. A grain met another grain and clung to it. Clumps met clumps. Over long ages, these gentle collisions built larger and larger bodies, first the size of pebbles, then boulders, then mountains, then small worlds called planetesimals, drifting quietly through the disk and slowly sweeping up everything in their paths. One of those growing bodies in this particular orbit around the young sun would become the Earth. It grew the way the others grew, gathering rock and metal and ice from the disk around it, a little at a time over millions of years. Each new piece that arrived added its small warmth and weight to the slowly assembling world. The young Earth grew hot as it grew large. Every piece of rock that fell into it carried energy, and all that energy turned to heat. Deep inside, radioactive elements added a slow warmth of their own. The growing planet became hot enough that much of it turned soft and molten, a glowing sphere, still gathering, not yet a world with a surface you could stand upon. In that molten state, the Earth slowly sorted itself. The heaviest materials, mostly iron, sank gently toward the center and gathered there, forming a dense metal core. The lighter rock floated upward and surrounded it. This quiet separation, deep inside the young planet, set up the layered structure the Earth still has today, a metal heart wrapped in thick stone. The forming of the iron core was one of the most important quiet events in the Earth's history. The slow stirring of that metal center, then and now, generates the planet's magnetic field, an invisible shield that reaches far out into space and gently turns aside much of the harsh wind blowing from the sun. The seed of that protection was planted in these first molten ages. By around 4.5 billion years ago, the Earth had gathered most of its mass. It was roughly the size it is today, but it was nothing like the world we know. There were no oceans, no continents, no sky we would recognize. It was a dark, hot, restless sphere, still glowing in places, still being struck by the last of the drifting debris, only just becoming a planet at all. It is worth pausing on how unhurried all of this was. The cloud drifted for ages. The collapse took ages. The gathering of the Earth took tens of millions of years of gentle, relentless accumulation. Nothing about the making of a world is fast. It is, from beginning to end, one of the slowest and most patient processes there is. The Earth did not form alone in this. All around it, in the same turning disk, the other planets were gathering at the same time, each sweeping up its own region of dust and rock. The small inner worlds grew stony and dense. The great outer worlds gathered vast envelopes of gas. Our Earth was simply one quiet member of a family of worlds, all being made together out of the same patient cloud. Not everything in the disk became a planet. A great deal of rock and ice was left over, drifting in the spaces between the new worlds. Much of it still drifts there today, in quiet belts of asteroids and distant fields of comets, the unused material of creation, gently circling, never gathered into anything larger. Some of it would much later bring water gently to the young Earth. The young Earth's very first air did not last. Whatever light gases it gathered from the disk, the lightest and fastest of all, slowly escaped back into space, too swift for the warm young planet to hold. The air we would come to know did not come from the cloud at all. It would be breathed out later and more slowly from the hot interior of the Earth itself. And the young Earth was not yet finished being shaped. One more enormous event still lay ahead of it, a slow-motion encounter with another young world, an encounter that would give the Earth its closest and most faithful companion. Let us drift gently now toward the birth of the Moon. The first great age of the Earth is called the Hadean. The name comes from Hades, the old word for the underworld, because the world in those ages was a place of heat and glowing rock. We will visit it gently from a safe and quiet distance, the way one might look at a distant fire from across a calm, dark valley, feeling none of its heat. In the Hadean, much of the Earth's surface was molten. So much energy had been delivered by the long gathering of the planet, and by the last great impacts, that the outer layers were a deep ocean of liquid rock. It glowed softly in the dark, dull red and orange, slowly stirring with no solid ground anywhere upon it. The whole young world was, in a sense, still cooling down from its own making. There were no oceans of water in the Hadean because it was far too hot for water to gather. Any water present existed only as scalding vapor high in a thick, heavy atmosphere of steam and volcanic gases. That early sky was nothing like ours. It was dense and dark and warm, pressing down on the glowing surface, holding the planet's heat close around it. The young Earth still gathered the last drifting pieces of its making. From time to time, a large body would arrive out of the dark and join the planet, adding its energy in a slow flare of light and heat. These late arrivals were part of how the Earth finished forming. Seen from far enough away, across the quiet of space, even they were only gentle pulses of light on a dim world. Slowly, though, the Hadean Earth began to cool. A glowing surface radiates its heat away into space, a little at a time, and over long ages even an ocean of molten rock loses its warmth. The brightest red faded toward dull gray. Thin skins of dark solid rock began to form across the surface, breaking and sinking and reforming, like the changing crust on slowly cooling lava. This cooling was not steady or smooth. The young crust formed and broke and melted again many times. For a long while the Earth had no permanent surface at all, only a restless boundary between fire below and heavy sky above. And yet beneath the restlessness, the overall direction was always the same, slowly, patiently, irreversibly toward a cooler and quieter world. Even in the Hadean, the deep structure of the modern Earth was already being set. The iron core was in place, slowly stirring. The thick rocky mantle surrounded it. The first faint magnetic field was already reaching out into space. The world was assembling its hidden architecture long before it had a single feature we would recognize at its surface. For a long time, the Hadean was imagined as relentlessly hellish from beginning to end. But the tiny zircon crystals from Western Australia hint at something gentler. Their chemistry suggests that, surprisingly early, there may already have been some liquid water at the surface, at least in places, at least sometimes. The world may have begun to cool and soften sooner than anyone once thought. So the Hadean was not only fire, it was also the slow turning of fire toward stone, and of scalding vapor toward the possibility of rain. Everything that would make the earth a living world, solid ground, liquid water, a calmer sky, was being prepared in these hot, quiet ages, slowly, beneath the heavy dark. It is strange and calming to think that the ground beneath every quiet meadow and still lake today was once a glowing, restless sea of rock. Nothing about the earth's gentleness was there at the start. All of it had to cool slowly into being. Across ages longer than we can feel, patience made the world. The heat of the Hadean came from several quiet sources together. There was the energy of all the rock that had fallen in during the long gathering. There was the warmth released as the heavy iron sank to form the core, and there was and still is the slow, steady heat of radioactive elements deep within, decaying gently across billions of years. The earth was warmed in part from the inside out. Even now, that deep inner heat has never fully faded. It still rises slowly from within, still stirs the mantle, still drives the drifting of the continents and the breathing of the volcanoes. The fire of the Hadean did not go out. It only sank deep inside the earth, where it still turns quietly beneath every calm landscape tonight. In the Hadean, two kinds of rock were slowly separating. The dark, heavy rock that floors the oceans, and the lighter, pale rock that would one day make the continents, began their long, quiet sorting. The lighter rock, once formed, tends to stay at the surface rather than sink, and so age after age, it slowly gathered the first faint beginnings of permanent land. And before the Hadean fire had fully settled, the young earth met another world in the dark, a slow, immense encounter that would change it forever and give it the pale companion that still lights our nights. Let us drift gently toward that meeting. In the early solar system, the spaces between the young planets were not yet fully swept clear. Other large bodies still drifted along their own slow orbits around the Sun. According to the best understanding we have, one of these was a world roughly the size of Mars. Scientists have given it a quiet name, Theia. Its path and the Earth's path were slowly, gently converging. About 4.5 billion years ago, Theia and the young Earth met. It was not a sudden, violent flash, the way such things are sometimes pictured, but an enormous, slow-motion encounter between two worlds. They came together along a grazing path, and over a span of hours, the smaller world merged into the larger one, both of them softening in the tremendous warmth of the meeting. Most of Theia was absorbed into the Earth, adding to its mass and its metal core. But the encounter also lifted an enormous quantity of rock off both worlds and flung it gently outward into a glowing ring that settled into orbit around the Earth, a faint, warm, slowly turning disk of debris circling the wounded young planet in the dark. That ring did not stay a ring for long, as deep time measures things. The countless pieces within it drifted and touched and gathered, the same patient way the planets themselves had gathered from the disk around the sun. Out of the ring, a single new body slowly took shape and grew round and solid. It was the moon, newly made from the substance of two worlds. The newborn moon was nothing like the small distant light we see tonight. It was far closer to the Earth, perhaps 10 times closer than it is now. In the young Earth's sky it would have hung enormous, a great pale glowing face, far larger than anything we ever see. The two worlds were close companions from the very beginning, bound together by gravity in the quiet dark. Because the moon was so close, its pull on the Earth was powerful. The early tides were immense, far greater than today's, sweeping slowly across the young oceans once they formed, and the Earth itself was spinning much faster then. A single day in those ancient ages lasted only about 5 or 6 hours. The world turned quickly beneath a great near moon. Ever since that time, the moon has been very slowly drifting away from the Earth, only a few centimeters each year, about the rate at which fingernails grow. Across billions of years, those quiet centimeters have added up to its present distance. And as the moon has drifted outward, the Earth's spin has gently slowed, lengthening the day hour by hour across the ages to the 24 we know. The moon does something quiet and important for the Earth. As the planet turns, it would naturally wobble on its axis over long spans of time, the way a spinning top wanders before it steadies. The moon's steady gravity holds that wobble gently in check. Because of the moon, the Earth's tilt stays calm and even, and the seasons keep their slow, reliable rhythm across the ages. So the same encounter that once wounded the young Earth also gave it a lasting gift. The moon has been a quiet companion to every age that followed, pulling the slow tides, steadying the seasons, lighting the nights of every creature that has ever lived, long before any of them existed to look up and notice it. There is something deeply restful in this. The moon you might see through the window tonight is made partly of the Earth and partly of a vanished world, shaped in a single slow ancient encounter, and drifting away from us so slowly that no one will ever feel it move. It has lit the dark for 4.5 billion years, and it will go on doing so long after this night is over. How can anyone know the moon was made this way? The quiet evidence is in the moon itself. The rocks the astronauts gently carried back are remarkably similar to the rocks of the Earth's outer layers, as if they share a single origin. The moon also has only a very small iron core, just as it would if it formed mostly from the rocky outsides of two worlds after the heavy metal had already sunk away inside the Earth. Over the long ages, the moon's spin slowly settled into a gentle rhythm with its orbit until it turned exactly once for each time it circled the Earth. Because of that quiet balance, the moon always shows us the same calm face, and always has all through human history. The far side was never seen by anyone until spacecraft drifted quietly around it. The moon also keeps a record the Earth has lost. Its quiet gray surface still holds the marks of the heavy bombardment of the early solar system, preserved because the moon has no rain, no wind, and no drifting continents to erase them. When we look at its calm, pocked face, we are seeing gently the youth that the earth itself has long since smoothed away. With the moon in the sky and the great heat of the Hadean slowly fading, the earth was ready for the next quiet transformation, the cooling of its surface into lasting stone, and the long, long fall of the first rain. Let us drift gently toward that. As the Hadean fire faded, the earth's surface slowly hardened. Heat radiated quietly away into space, age after age, and the molten outer layers thickened and stilled. Thin sheets of dark solid rock spread across the surface, broke apart, sank, and formed again, until at last a more lasting crust began to hold. The world was growing a skin of stone. The very oldest surviving pieces of that early world are rare and precious. There are rocks in northern Canada and Greenland that are close to 4 billion years old, and the tiny zircon crystals of Western Australia are older still. These are the Earth's first quiet memories of having a surface at all, small fragments that have somehow survived an almost unimaginable depth of time. Above the cooling crust hung the heavy early atmosphere. It was thick with the gases that volcanoes breathe out, carbon dioxide, nitrogen, and an enormous quantity of water held as scalding steam because the world was still too warm for it to gather as liquid. The sky in those ages was a dense, dim, clouded ceiling, pressing its warmth down over the dark new stone. Then, slowly, the surface cooled past a quiet threshold. It became cool enough that the steam in the sky could no longer stay a vapor. High in that heavy atmosphere, water began to gather into the first true clouds, and from those first clouds, after ages of only fire and stone, the first rain began to fall upon the earth. First rains did not last a season. They lasted, in a sense, for ages. So much water was held in that early sky that once it began to fall, it fell and fell across an immense span of time. Warm rain ran over the bare, dark rock, gathered into the low places, and slowly, patiently began to pool. The earth was filling its first hollows with water. There were no plants to soften the land, and no soil to hold the water. The rain fell on bare stone and ran freely across it, finding the lowest ground. There it gathered into shallow, warm seas under a still, dim sky. These were the earth's first oceans, not yet blue and bright, but warm, quiet, and slowly spreading across the patient dark rock. As the rain fell and the seas gathered, the heavy sky slowly thinned. Much of the water that had pressed down as steam was now resting quietly on the surface as liquid. The atmosphere grew lighter and a little clearer. The world was passing gently from a planet wrapped in hot vapor to a planet with sky above and sea below, the basic shape it has kept ever since. The first crust was thin and restless compared with the continents of today. It was mostly dark volcanic rock, broken and reworked again and again by the heat still rising from within. Here and there, lighter rock began to gather into small low platforms, the faint first beginnings of what would, across billions of years, slowly grow into continents. All of this unfolded with no witness, and in near silence, only the sounds of rain and water, and the slow settling of stone under a sky no eye yet watched. The Earth was quietly assembling the stage on which the entire story of life would one day take place, ages before the first living thing existed to stand upon it. It is a calming thought as the rain falls outside on any quiet night, that rain is one of the oldest gentle processes on the earth. The first rain fell 4 billion years ago onto bare warm stone, and rain has been falling somewhere ever since. The same slow patient cycle that filled the first seas is still turning quietly tonight. The tiny zircon crystals are remarkable timekeepers, and they carry more than an age. Locked within their chemistry are faint hints of the world they formed in, signs that there was already liquid water at the surface, and perhaps even the first rafts of lighter continental rock, surprisingly soon after the Earth was made. From specks far too small to see, we read the temper of an entire vanished age. As the crust steadied, the first lasting pieces of continent began to gather. These ancient cores, called cratons, are the oldest, calmest hearts of the land. They have survived deep and stable through everything the Earth has done since. The quiet centers of several continents today are built around rock that has rested almost undisturbed since these very early ages. With rain falling and seas gathering, the Earth's great water cycle quietly began, and it has never stopped since. Water rose as vapor, gathered into cloud, fell as rain, ran across the rock, and returned to the sea, only to rise again. That patient circle slowly began to wear at the bare stone and carry fine sediment into the seas, the first slow shaping of the land by water. Now the earth had its first oceans, spread warm and shallow under a thinning sky, where that water had come from, and what it would soon make possible is the next quiet part of the story. Let us drift gently toward the origin of the seas. The Earth's oceans are so familiar that it is easy to forget they had to come from somewhere. The water did not arrive all at once, and it did not come from a single source. It gathered slowly over a very long time from two quiet origins working gently together, water breathed out from inside the planet, and water carried in from the cold reaches of space. Much of the water came from within the Earth itself. The rock that built the planet held water locked inside its minerals, in tiny amounts all through it. As the young Earth heated and its volcanoes worked, that water was slowly released as steam, age after age, breathed gently into the early sky, and then in time rained down to gather in the seas. Some of the water came from much farther away. In the early solar system, countless icy bodies drifted in from the cold outer regions and joined the young Earth, carrying frozen water with them. The careful study of the kinds of water in the oceans today suggests that this delivered water, especially from icy asteroids, made up a real part of the seas. From both sources together, across tens of millions of years, the water gathered. The early Earth may have been almost entirely an ocean world. Its shallow, warm seas spread across nearly the whole surface, with only small scattered platforms of rock standing above the water. The blue of the planet in those ages was very nearly unbroken. There is a quiet puzzle in these early seas. The young sun was noticeably fainter than it is today, perhaps a third less bright. By simple reckoning, the Earth should have been frozen solid, and yet the rocks show liquid water, warm and abundant. The faint young sun should have left an ice world, and instead there was a gentle sea? The answer lies in the early sky. The thick atmosphere of that time was rich in carbon dioxide and other warming gases breathed out by volcanoes. Like a soft blanket, that air held the weak sunlight's warmth close to the surface. A faint sun and a thick warming sky balanced each other, and the seas stayed liquid, gentle and warm across the ages. The first oceans were not like the clear blue water of today. They were warm, and their chemistry was very different. There was no oxygen dissolved in them. They held a great deal of dissolved iron, which gave them a faint greenish cast. The early sea was a quiet, warm, iron-rich water under a dim sky, gentle, but unlike anything that exists now. Around the edges of these seas, and along the cracks in the seafloor, warm, mineral-rich water flowed up from inside the earth. Hot springs and gentle vents released a steady supply of dissolved chemicals into the water. These quiet meeting places where the planet's inner chemistry mixed with the early ocean would prove to be unusually important. The oceans also began the slow work they have done ever since. They absorbed warmth and carried it gently around the world. They took in gases from the sky and gave others back. They wore slowly at the bare rock and carried fine sediment into their depths. The seas became the patient regulators of the Earth's surface, calming and balancing the young world. It is restful to think that the water resting in any quiet sea or still glass tonight is almost unimaginably old. The same water has cycled through sky and sea and stone for 4 billion years, breathed out by volcanoes and carried in on ice, falling as rain and rising again over and over, long before anything lived to drink it. The early sea was not yet salty the way the ocean is today. Its salt has gathered slowly, age after age, carried in by rivers wearing gently at the rock and by minerals rising from the seafloor. Over billions of years, those quiet contributions accumulated, and the sea became the gentle brine we know. The saltiness of the ocean is, in a sense, a slow measure of deep time itself. The seas also began their long work as the planet's slow thermostat. Carbon dioxide from the air dissolves gently into rain and sea, and over ages it is locked away into rock. When the world warms, this quiet process speeds up and draws the warmth down. When it cools, it slows and lets the warmth gather again. Across deep time, this gentle balance has kept the Earth, more often than not, mild enough for water to stay liquid. It is this quiet balance, more than anything, that has kept the Earth gentle for so long. The sea and the sky and the rock have been in slow conversation for 4 billion years, each steadying the others, each answering the other's changes across ages. The result has been a world that, again and again, has drifted back toward the mild and the liquid and the calm. And in these warm, quiet, mineral-rich early seas, under a dim and gentle sky, the Earth was about to do the most remarkable thing it has ever done. Very softly, almost imperceptibly, it was about to come alive. Let us drift gently toward the first whisper of life. We come now to one of the quietest and most mysterious moments in the whole story of the Earth, the moment when the planet, until then only rock and water and air, very softly became a living world. No one knows exactly how it happened or precisely when, but the rocks tell us that it happened early and that it happened gently in the warm dark of the first seas. Before there was life, there was chemistry. The early Earth was rich in simple ingredients: water, carbon dioxide, nitrogen, minerals, and energy from sunlight, lightning, and warm vents. Over long ages, these simple things combined into more complex ones. Slowly, patiently, the ordinary chemistry of a young planet was assembling the gentle building blocks that life would one day be made of. There are two quiet places where this slow assembly may have happened. One is the warm, shallow pool at the edge of the early sea, where water gathered, warmed, and concentrated its chemistry under a dim sky. The other is the deep vent on the seafloor, where mineral-rich water rose gently and warm from inside the earth. Both were calm, sheltered, patient places. Somewhere in such a place, the chemistry crossed a soft and invisible line. A molecule appeared that could gently copy itself using the materials around it. Once something could make a quiet copy of itself, the slow, patient work of life had begun. There was no sudden spark and no single moment anyone could have pointed to, only chemistry very gradually becoming biology. The first life was unimaginably simple, far simpler than a single modern cell. It had no body and no form we would recognize. It was only a thin, fragile chemistry, wrapped perhaps in a gentle film, drifting in warm water, slowly making more of itself. And yet every living thing that has ever existed on the earth is descended, without a single break, from that quiet beginning. All life on earth today shares a deep common chemistry, which tells us it all flows from a single ancient source. Scientists call that source the last universal common ancestor, not the first life, but the quiet ancestral population from which everything living has come. It lived in the early seas billions of years ago, and we are all, in the most literal way, its distant continuation. The oldest gentle hints of life are very old indeed. In rocks from western Greenland close to 4 billion years old, there are faint chemical traces that may be the signatures of early life. In Western Australia, there are layered structures around 3.5 billion years old that appear to have been built by living microbial communities. Life, it seems, arrived softly and early. It is worth pausing on how quietly this all happened. There was no announcement and no witness. The early sea looked exactly the same the age after life began as it had the age before. A living world and a lifeless one in those first times were almost indistinguishable from any distance. The most important change in the planet's history was also one of its gentlest. This faint new presence did not yet change the face of the earth. The continents, the sky, the seas, all carried on as before. Life was, for now, only the thinnest of films on a vast and patient planet, a quiet guest, newly arrived, with billions of years of slow work still ahead of it before it would reshape the world. There is a deep calm in the thought that life began so gently and has never once stopped from that first quiet, self-copying chemistry in a warm early sea. An unbroken thread runs across nearly 4 billion years, through every age the earth has known, all the way to the slow breath you are taking now, in the dark, as you rest. What does it mean gently for something to be alive? At its simplest, a living thing draws energy and material from around it to keep itself going, and it makes quiet copies of itself that carry its pattern onward. The first life did only this, and barely. There was no breath, no movement we would notice, No awareness, only chemistry that maintained itself and continued. From that small definition, everything else has slowly grown. One gentle idea is that the earliest life leaned on a single kind of molecule that could both carry a pattern and help copy it, a quiet forerunner of the more elaborate machinery in cells today. Whether or not the details are ever fully known, the shape of the story is calm and clear. Simple chemistry, given warmth and water and time, slowly found a way to continue itself. We may never know the exact place or moment, and there is a calm in accepting that. The origin of life happened so long ago, and the rocks of that age are so few that its details are gently lost to deep time. What we can say is simple and reassuring. It happened early, it happened quietly, and it has never since stopped. For the next 2 billion years, this quiet life would have the Earth almost entirely to itself in the form of countless invisible microbes. That long microbial age is the next part of our slow story. Let us drift gently into it. For an immense stretch of the Earth's history, far longer than all the rest of the story put together, life was entirely microscopic. There were no plants, no animals, nothing visible to an unaided eye. The whole living world was a thin, invisible film of single cells, drifting in the seas and resting on the rocks. This is sometimes called the Long Age of Microbes, and it lasted about 2 billion years. The Earth of this age belongs to the time geologists call the Archean. The sky was not blue. The air held no free oxygen at all. It was a mixture of nitrogen, carbon dioxide, and methane, and a gentle haze of organic particles may have given the sky a soft orange cast. A traveler from today would not have been able to breathe that air, and yet for the microbes it was home. The continents, too, were only beginning. Instead of the great land masses of today, there were small, scattered platforms of lighter rock, the ancient cores that geologists call cratons. Slowly, over hundreds of millions of years, these cores grew and gathered, the first patient drafts of the continents that would one day exist. In the shallow seas, microbial communities spread across the floor in soft living mats, layered sheets of countless cells growing gently in the warm, dim water. Where conditions were right, these mats trapped fine sediment and slowly built it upward into low domed mounds of fine layers called stromatolites. They grew at the pace of stone, a hair's width in a human lifetime. These stromatolites are among the oldest signs of life preserved anywhere on Earth. Their patient layers, found now in ancient rocks across many continents, are quiet records of microbial life that thrived in warm, shallow seas more than 3 billion years ago. Each mound is a slow book, written one fine layer at a time across thousands of years. Some of these early microbes lived on the chemistry of the planet itself, drawing energy from minerals, from warmth, from the gases dissolved in the sea. Others slowly learned to use the light of the dim sun. This was the gentle invention of photosynthesis, and although nothing about it looked dramatic, it would across vast time change the whole world. In the iron-rich early oceans, a slow chemistry left a beautiful record in stone. Season after season, age after age, fine layers of iron and silica settled gently onto the seafloor, building up striped rock called banded iron. These quiet bands, red and dark and patient, are among the most striking pages the Archean ever wrote, and we will return to what they mean. Nothing about this age was fast. For roughly 2 billion years, the broad picture of the Earth changed only very slowly. The same kinds of microbes did the same kinds of slow chemistry in the same kinds of warm, shallow seas, age after age after age. It was the longest, quietest, most patient chapter in the planet's entire biography. And yet, beneath that stillness, something enormous was slowly accumulating. The light-using microbes were releasing a strange new gas into the water and very gradually into the air. At first, the world quietly absorbed it, age after age, but it was building slowly toward a threshold, toward one of the greatest transformations the Earth would ever pass through. There is a profound calm in this long microbial age. For 2 billion years, the Earth simply turned, and the microbes simply lived, and nothing was in any hurry at all. The world did not need drama to do its deepest work. It only needed time, and of time it had a great and patient abundance. The microbes of this age lived in many quiet ways, and together they gently painted the world. Some drew energy from sulfur, some from iron, some from the simple gases of the early air. Each kind subtly changed the water and the rock around it. The Archean world was, in a sense, slowly colored and shaped by the patient chemistry of unseen life. The microbial mats themselves were quiet little worlds. Within a single soft sheet, different kinds of microbes lived in fine layers, each at the depth that suited it, each living on what the others released. These mats were the Earth's first communities, gentle, layered, cooperative ecosystems built entirely of cells too small to see, spread across the floors of warm, shallow seas. Why did this age last so unimaginably long? Perhaps because the simplest life, once it works, has little reason to change. For nearly 2 billion years, the world offered the microbes a steady living, and they took it quietly, without needing to become anything more. The long stillness was not failure, it was a kind of deep, patient success. That slowly gathering new gas was oxygen, and the moment it finally rose into the sky is one of the great quiet turning points in the Earth's history. Let us drift gently toward the Great Oxidation. For most of the long microbial age, the Earth's air held no free oxygen at all. The gas we breathe without thinking simply was not there. Then, very slowly, across hundreds of millions of years, that changed. The change was so gradual that no one alive in any single age could have noticed it, and yet it remade the entire planet. It is called the Great Oxidation. The oxygen came from the smallest of sources. Tiny light-using microbes in the shallow seas, often called cyanobacteria, as they used the dim sunlight to power their chemistry, they released oxygen as a quiet byproduct, a little at a time, in every sunlit patch of water. No single cell mattered, but across the whole world, across vast time, they were enough. At first, the new oxygen did not gather in the air. The early oceans were full of dissolved iron, and the oxygen bound quietly to that iron instead. Age after age, the iron and oxygen settled together onto the seafloor in fine alternating layers, building the striped banded iron rock we met before. The world was slowly, patiently rusting beneath its seas. Only after the ocean's iron had largely been used up could oxygen begin to gather elsewhere. It moved slowly into the air. Around 2.5 billion years ago, free oxygen finally began to remain in the sky in lasting amounts. It was still far thinner than today's air, but for the first time the Earth had an oxygen atmosphere at all. On land, the new oxygen left its mark in color. The bare rock, rich in iron, slowly reddened as it weathered in the oxygen-touched air, exactly as iron reddens with rust. Across the ages, the world's exposed stone took on the warm red tones still preserved in ancient rock layers today. The Earth was very gently changing color. For the microbes that had ruled the oxygen-free world, this rising oxygen was a profound change. To much of the older life, oxygen was unfamiliar and harsh. Many of those ancient communities slowly retreated into the quiet places where oxygen could not reach, deep mud, still water, the dark within the rock, where their descendants live to this very day undisturbed. The rise of oxygen also touched the sky's warmth. The old atmosphere had been kept gently warm in part by methane, and oxygen slowly removed much of that methane from the air. With its soft blanket thinned, the world cooled. Around this time, the Earth passed through one of its first long cold ages, with ice spreading far across the surface. That early cold age was long, but the Earth did not stay frozen. Volcanoes continued their slow, quiet work, breathing carbon dioxide back into the air across ages, and the soft, warming blanket gradually thickened again. The ice withdrew. The world settled into a new and steadier balance, now with oxygen quietly present in its sky. It is worth holding this gently. The air you are breathing now, easily and without thought, is the slow gift of countless invisible microbes working in dim ancient seas for hundreds of millions of years. Every quiet breath tonight reaches back, unbroken, to their patient and unhurried work. With oxygen in the sky, a door had opened. New kinds of life, able to use oxygen's energy, would one day become possible, though not for a long while yet. The Earth, having been transformed, now entered one of its calmest and most stable stretches of all. For the older oxygen-free life, the rising oxygen was the greatest change their world had ever known. To much of it, oxygen was harsh and unfamiliar, and yet this was not a calamity so much as a slow turning. Some life retreated to quiet, sheltered places. Some slowly learned to use the new gas and found in it a powerful source of energy. The world did not end. It simply, gently became different. On the land, the change was written in color and stone. Where bare rock met the new oxygen-touched air and water, it slowly weathered red, and rivers carried that reddened sediment into low basins. Across the ages, it gathered into thick red rock layers still found today, quietly recording the age when the Earth's stone first learned to rust. That first long, cold age, brought on as the methane faded, was severe but not final. It is a quiet lesson the Earth repeats through its whole story. A great change in the air brings a great change in the climate, and then, slowly, the patient processes of the planet draw it back toward balance. The world cooled deeply, and then, in time, it gently warmed again. That long, stable stretch, and the deep cold that followed it, is the next quiet part of our story. Let us drift gently toward the calm Middle Ages of the Earth and the great ice that ended them. After the Great Oxidation, the Earth entered an age of remarkable calm. For roughly 1 billion years, from about 1.8 to about 800 million years ago, the planet's chemistry and climate changed very little. Geologists sometimes call it fondly the boring billion, but there's nothing dull about a world that holds itself gently steady for 1,000 million years. During this quiet billion, the oceans were layered and still. Oxygen remained thin in the air and scarce in the deep sea. Life remained almost entirely microbial, though the more complex single cells were slowly, quietly growing more capable. It was a long, patient, low plateau in the story, the Earth holding its breath, gathering itself without hurry. Then, toward the end of that long calm, the Earth passed into one of the most extraordinary episodes in its history. The climate cooled and did not stop cooling. Ice spread from the poles toward the middle of the world. Glaciers reached down to the warm latitudes. The planet was sliding into a deep and almost total cold. This was the time of what is often called Snowball Earth. In at least 2 long episodes, a little over 700 and again around 650 million years ago, ice may have reached almost all the way to the equator. The oceans froze over across enormous areas. From far away, the Earth would have looked like a pale, quiet, white world. Even in this deep cold, the Earth was never fully still. Beneath the ice, the oceans remained liquid and dark, and life endured quietly within them. Around warm vents and in sheltered water, the microbes carried on, patient as ever. The snowball ages were severe, but life having begun, simply waited the cold out in the gentle dark below. What slowly ended the great ice was the quiet patience of volcanoes. On a frozen world, the usual slow process that removes carbon dioxide from the air nearly stops. But volcanoes keep breathing that gas out, age after age. Across millions of years it gathered in the sky, thickening the warming blanket, until at last the ice began very slowly to give way. When the thaw came, it came gradually. Over long ages the ice withdrew, the dark seas opened again to the sky, and the world warmed back toward gentleness. The Earth had passed through one of its hardest trials and emerged quietly on the other side, colder and warmer by turns, but always in the end finding its balance again. The end of the great ice ages was followed, not long after in deep time terms, by a remarkable quickening of life. The long microbial plateau was ending. In the seas that opened after the snowball, the first soft, simple, many-celled creatures appear in the rocks, gentle drifting forms, the quiet forerunners of all the animal life to come. It is a calming pattern, repeated across the Earth's whole history. The world cools and warms, the ice advances and withdraws, the air thickens and thins. Again and again, conditions swing far in one direction, and again across patient ages, the slow processes of the planet draw it gently back toward balance. There is rest in that pattern. Whatever the Earth has passed through, fire, then ice, then fire again, it has always given enough quiet time, found its way back to gentleness. The planet does not panic, it simply continues and slowly rights itself across spans of time longer than worry can reach. How do we know ice once reached the warm middle of the world? The rocks themselves remember it. In places that lay near the equator in those ages, geologists find the unmistakable debris that only glaciers leave, ground rock and scattered stones, dropped quietly by melting ice. Stone carried by ice, resting in what were once the tropics, is the calm, clear signature of a frozen world. The thaw left its own quiet mark. Directly above the glacial rock all around the world lies a distinctive pale layer of carbonate stone, formed as the warming seas drew down the thick carbon dioxide that had ended the ice. These quiet cap layers rest gently on the glacial debris like a soft closing page recording in stone the moment the great cold gave way. It is calming that even the Earth's most extreme moods left such quiet, readable traces. A frozen world and its slow thaw are not remembered as drama, but as two soft layers of rock, one resting gently on the other, waiting patiently in a cliff face for someone ages later to read them. Through all of this, the calm billion, the great ice, the gentle thaw, the continents themselves had never been still. They had been wandering slowly across the face of the earth the whole time. That slow wandering is the next part of our story. The map of the earth has never been fixed. The continents we know are not permanent fixtures, but slow travelers drifting across the surface of the planet over hundreds of millions of years. They have been doing this since the early ages, and they are still doing it tonight, far too slowly for anyone to feel. The movement is driven from deep within. Beneath the thin crust lies the mantle, a vast thickness of hot rock that flows unimaginably slowly, like something between stone and syrup. Warmth from the Earth's interior keeps it gently stirring, in slow, patient loops that take many millions of years to turn even once. The Earth's hard outer shell is broken into great pieces called plates. They rest upon the slowly stirring mantle and are carried along by it. Where the deep rock rises, plates are gently pushed apart, and new seafloor is born along the gap. Where plates meet, one may slide quietly beneath another and return over ages into the depths. All of this happens at the pace of a growing fingernail, a few centimeters a year. It is far too slow to see in a lifetime or in 1,000 lifetimes, but the Earth has all the time there is. Across hundreds of millions of years, a few centimeters a year is enough to carry a continent from one side of the world to the other. Where wandering continents slowly collide, the crust crumples gently upward over millions of years, and mountains rise. Every great range on Earth, even the highest, was lifted this way, with infinite slowness, by continents leaning into one another. And from the moment they rise, wind and water begin, just as slowly, to wear them back down. Over the long history of the Earth, the continents have done something remarkable again and again. Slowly, across hundreds of millions of years, they have drifted together into a single great landmass, a supercontinent. Then, just as slowly, they have broken apart and dispersed, only to gather once more in a different arrangement ages later. This gathering and parting is so regular that it has a name, the supercontinent cycle. Long before the one most people have heard of, there were earlier ones, gathered, named by geologists, and long since dispersed. The continents have rehearsed this slow dance many times over, patiently, across the deep history of the world. When the continents gather, They change the whole world. A single great landmass has a vast, dry interior far from any sea, and the climate everywhere shifts. When they break apart, new oceans open between them, new coastlines appear, and the patterns of warmth and water are gently redrawn. The slow wandering of the land quietly rules the climate of every age. The rock itself remembers all of this. Ancient stone carries the faint magnetic record of where it lay when it formed, like a compass frozen in place. By reading those quiet signals, geologists can slowly trace the long journeys of the continents and reconstruct maps of an Earth that no eye ever saw. There is something restful in knowing the ground itself is slowly traveling. The land beneath any quiet room tonight is not truly still. It is drifting, gently, a few centimeters a year, carried on the slow, deep currents of a patient planet, exactly as it has been for billions of years and will be for billions more. There is a quiet evidence for all this slow movement, written in the floor of the sea. As new seafloor forms along the great rifts, it records the direction of the Earth's magnetic field in the rock, and that field reverses gently from age to age. The result is a pattern of mirrored magnetic stripes spreading outward from the rifts, a calm, clear record that the ocean floor itself is slowly being made and carried apart. The rock itself is endlessly recycled. Stone is lifted into mountains and slowly worn to sediment. Sediment is buried and pressed into new rock. Rock is carried down into the depths and melted, and rises again as fresh stone through volcanoes. Nothing about the Earth's surface is permanent. It is all slowly remade again and again in a patient cycle with no beginning and no end. The idea that continents drift was once thought impossible, and it was accepted only slowly over decades as the quiet evidence gathered. There is a calm lesson in that patience too. The Earth gives up its deepest secrets gently to those willing to read its rocks slowly and wait. The truth was there all along, written in stone, waiting only to be understood. As the continents wandered and the great ice withdrew, the seas filled quite suddenly in deep time terms with the first complex life. That flowering in the ancient oceans is the next part of our story. Let us drift gently toward the Cambrian Seas. After nearly 4 billion years in which life stayed small and simple, the Earth's seas changed in deep time terms quite suddenly. Beginning a little over 530 million years ago, the shallow oceans filled across a few tens of millions of years with complex life of many kinds. This quiet flowering is called the Cambrian, and it is when the seas truly came alive. Part of what made this possible was simply oxygen. Across the long ages, it had slowly risen in the sea and air until at last it crossed a quiet threshold, enough to support larger, more active, more complex bodies than the world had ever held. The Earth had patiently prepared the conditions, and life gently expanded to fill them. In the Cambrian Seas, life first took on hard parts, shells, plates, and fine mineral skeletons. This was a gentle revolution. Hard parts protected soft bodies, and they also preserved beautifully. For the first time, the rocks begin to fill with clear, detailed records of life, where before there had been only faint traces and impressions. The seafloor itself was transformed in the older world. The mud of the seabed had been a still, undisturbed surface. Now, for the first time, creatures burrowed down into it, mixing and aerating the sediment. This quiet reworking of the very floor of the sea changed the chemistry of the oceans and opened still more room for life. The Cambrian Seas also built the first true reefs. Communities of organisms grew gently upward together, layer upon layer, raising low, quiet structures from the seafloor toward the light. These early reefs were the distant ancestors of every reef since, slow, patient architecture built without plan, across thousands of unhurried years. In a few rare and gentle places, even the soft-bodied life of these seas was preserved. Fine, quiet mud settling slowly over delicate forms kept their faint shapes across 500 million years. These rare windows let us glimpse a whole living sea that would otherwise have vanished completely, a quiet gift from patient sediment. It is worth keeping the focus gently on the world itself. The Cambrian was not only a change in life, but a change in the earth, in the chemistry of its seas, the texture of its floors, the clarity of its waters, the very record kept in its stone. The planet and its life were changing together, each slowly shaping the other. These seas were warm and shallow and gentle, spread across the low edges of the wandering continents. There were no creatures on the land at all. The shores were bare rock and sediment, quiet and empty, while just offshore the shallow water had become, for the first time, richly and intricately alive. From this Cambrian flowering, the variety of life in the seas slowly continued to grow across the ages that followed. Reefs widened. The shallow waters filled with gentle communities. The oceans became gradually the rich, quiet world they have remained ever since, though still for a long while, leaving the land entirely empty above the tide. There is a calm in the thought that the sea has been intricately alive for over 500 million years, long before any forest, any footprint, any sound on land. The shallow oceans were already full of quiet, patient life, doing slowly exactly what life still does, continuing gently without hurry in the warm lit water. The Cambrian flowering did not come from nothing. Just before it, in the seas that followed the great ice, there were already gentle, soft-bodied forms, quiet, frond-like and disc-shaped beings, drifting and resting on the seafloor, leaving faint impressions in fine sandstone. They were the calm prelude, the soft first draft of complex life, before the seas grew richer still. With the Cambrian came senses, and with senses the sea itself changed. For the first time, life could see. A world that can be seen is a different world from one that cannot, even if the water and the rock are unchanged. The shallow seas became quietly a place of awareness as well as chemistry, the planet, in a sense, slowly opening its eyes. Almost everything we know of these seas comes from a few rare quiet places where even soft bodies were preserved. Most of that ancient life would have vanished without a trace. That so much can be read from so few gentle windows is a quiet reminder of how generous a little patient sediment in the right still place can be. With the seas richly alive, the great empty stage of the land was waiting. The slow green crossing onto bare rock is the next quiet part of our story. Let us drift gently toward the first life on land. For most of the Earth's history, the land was completely bare, across all the ages of fire and ice and wandering continents. While the seas slowly filled with life, the land remained quiet stone and sediment, swept by wind and rain, with nothing growing on it at all. The greening of the land happened late, and it happened slowly. Beginning around 470 million years ago, the first simple plants crept gently onto the land from the water's edge. They were low and small, clinging to damp ground near streams and shores. They had no roots and no leaves as we know them, but they were green, and they were the first living things ever to hold the open land. As plants slowly spread, they began to make soil. Their gentle growth and slow decay, working with rock and water, broke bare stone into the first true earth. Soil is a quiet living thing in its own right, and before plants there had been none anywhere on the planet. The land was very slowly becoming a place that could be lived upon. Over the following ages, plants grew taller and more ambitious. Roots reached down into the new soil. Stems learned to stand. By around 380 million years ago, in the time called the Devonian, the first true forest rose, quiet stands of tall, strange trees, the first time the earth had ever worn a canopy against the sky. Then came one of the gentlest and most consequential ages of all, the Carboniferous, roughly 360 to 300 million years ago. Across vast, warm lowlands, enormous quiet swamp forests spread, wetter and greener than any before. They grew and fell and grew again, layer upon patient layer, across millions of years. In those swamp forests, fallen plants did not fully rot away. They sank into still water and were slowly buried, age after age, pressed gently under their own accumulating weight. Over immense time, that buried plant matter became peat, and then, far deeper and slower, the dark seams of coal still resting in the rock today. This vast burial of plant matter quietly changed the air. As the forests grew, they drew in carbon dioxide and breathed out oxygen, and because so much carbon was locked away underground instead of returning to the sky, oxygen slowly rose to the highest levels in the Earth's history, a richer air than the world has known before or since. The same quiet burial gently cooled the world, pulling so much carbon dioxide out of the sky, thinned the soft warming blanket, and across the ages the climate slowly cooled, sliding toward another long cold age with ice gathering again toward the poles. The forests, simply by growing and being buried, had reshaped the whole planet's air and warmth. It is a calming thought that the coal resting deep in the rock is, quite literally, ancient sunlight. It is the gentle energy of a dim, long-ago sun, gathered by quiet swamp forests 300 million years ago, and folded slowly away into the dark stone, where it has rested patiently ever since. By the end of these ages, the land was no longer empty. It had soil and forests and a green presence under the sky. The earth had become at last a fully living world above the tide as well as below it, though the arrangement of its land was about to change profoundly. That richer air had gentle consequences across the whole world. With so much oxygen, even the damp lowland forests could hold their quiet abundance, and the air itself was thicker with life-giving gas than at any time before or since. The earth had reached a soft high point of breathable air, built quietly by forests over millions of patient years. The slow cooling that followed was the forest's quiet gift as well. By locking so much carbon into the ground, they thinned the warming blanket of the sky age after age, until the world drifted into another long, cold time, with ice gathering once more toward the poles. Simply by growing and being buried, the forests had gently reached up and changed the climate of the whole planet. These coal seams are a worldwide quiet signature of a single age. In many countries, in rock of just this time, the same dark bands of buried forest appear, resting in the layers like a shared chapter written across the whole earth. The planet kept the same patient record everywhere, in stone, of the ages when it first wore deep green forests. For as the forests grew, the wandering continents were slowly converging once more, gathering toward the greatest supercontinent of them all. Let us drift gently toward the age of Pangaea and the great quiet that followed it. Across the long ages, the wandering continents had been slowly converging. By around 300 million years ago, they had gathered, almost all of them, into a single vast landmass, the supercontinent that geologists call Pangaea, meaning all the earth. Around it spread one immense world ocean, quiet and unbroken, covering most of the planet. A single great continent makes a very particular world. Its center lay far from any sea, beyond the reach of ocean rains, and so the heart of Pangaea was a vast dry interior of quiet desert and wide still plains. The coasts were gentler and greener, but the inland was an immense calm dryness, larger than any desert today. Life had by now spread across both sea and land. The shallow oceans were rich with quiet communities, the land carried forests, and the first creatures had long since crept out of the water onto it. The world around 260 million years ago was as full of life as it had ever been, patient, varied, and gently flourishing. Then, around 252 million years ago, the earth passed through its deepest and quietest trial. We will move through it gently, from a calm distance, the way one might watch a far storm pass across a valley at night, knowing the morning will come. In what is now Siberia, the earth's interior breathed out for an immense span of time. Across many thousands of years, vast quiet floods of lava spread over an enormous region, and with them came great volumes of gas into the air. It was slow, and it was patient, and across the ages it gently changed the chemistry of the whole world. The air slowly warmed, the seas slowly changed. Across a long stretch of time, much of the older life gently gave way, and the world grew quieter than it had been in a very long age. This was the largest of all the great turnings of life, and yet told in deep time it was not a sudden moment, but a long, slow hush settling over the earth. It is worth holding this gently and without fear. The earth had passed through deep changes before, fire, ice, the turning of the very air, and it had always, given time, found its balance again. The great quiet was profound, but it was not an ending. The planet kept turning, the seas kept their tides, the slow processes carried on. And slowly the world began again. Life is patient and persistent, and from the quiet communities that endured, variety gradually returned. Across millions of years, the seas refilled with gentle life, the land grew green again, and the earth slowly recovered its abundance. The great quiet was followed, as every quiet is, by a slow, soft renewal. This is perhaps the most reassuring pattern in the Earth's whole story. Again and again, the world has been deeply changed, and again, it has gently begun again. Renewal has always followed quiet. The planet has never in 4.5 billion years failed to find its way slowly back toward life. There is rest in that. Whatever passes, the deep, slow processes of the earth continue beneath it, patient and unhurried, drawing the world quietly back toward gentleness, exactly as they always have. The night too passes this way, and the morning follows it without fail. A single great continent makes a world of extremes, and the rocks remember it gently. The vast interior, far from the sea, swung between dry heat and quiet cool, and great seasonal winds swept across it. Thick beds of pale desert sandstone, laid down by ancient dunes, still rest in many lands today, the calm preserved memory of Pangaea's enormous dry heart. The recovery after the great quiet was itself slow and patient, and it too is written in the stone. For a while the rocks hold only a sparse, simple record, and then, layer by layer across millions of years, the variety of life gently returns to them. The pages grow full again, unhurried, the way a quiet landscape slowly greens after a long winter. Seen across the whole of deep time, even the greatest turning was only a thin, quiet line between long ages of calm. The Earth's story is overwhelmingly one of slow, gentle continuity. The dramatic moments are rare punctuation. The long, calm sentences between them are nearly the whole of the book. It is a story whose deepest character is patience. Out of that slow renewal rose one of the most famous ages of all, a long, warm, gentle greenhouse world as Pangaea itself slowly began to break apart. Let us drift gently toward the age of giants. Out of the long, slow renewal came one of the most famous ages in the Earth's history, the Mesozoic, stretching from about 252 to 66 million years ago. It was a warm, gentle green world, and it is best known as the age when the largest creatures ever to walk the land lived quietly upon it. Tonight, we will look mostly at the world they lived in. Through these ages, the great supercontinent Pangaea was slowly coming apart. Long, quiet rifts opened across it, age after age, and into those widening gaps the sea gently flowed. A new ocean, the early Atlantic, was slowly being born along one of those rifts, narrow at first, then patiently widening across millions of years. As the continents drifted apart, they slowly took on shapes we would begin to recognize. The pieces of Pangaea were becoming very gradually the land masses of today, though set in different places and joined in different ways. The map of the modern world was being drawn with infinite slowness by the same patient wandering that had always moved the land. The Mesozoic world was warm almost everywhere. Carbon dioxide was abundant in the air. The soft, warming blanket was thick, and there were no great ice caps at the poles at all. Even the far north and far south were gentle and green. The whole earth was a mild, humid, quiet greenhouse, warmer and softer than the world we know. Because the world was so warm and the poles held no ice, the seas stood high. Shallow water spread far across the low edges of the continents, drowning vast areas under warm, calm, sunlit ocean. Much of the land we know today lay quietly beneath gentle, shallow seas through long stretches of these ages. In those warm, shallow seas drifted countless tiny shelled organisms smaller than dust. As they slowly settled to the seafloor, age after age, their fine, pale shells gathered into thick, soft layers. Across millions of years, those layers became chalk, and the quiet white cliffs that stand along some coasts today are made entirely of that gentle ancient rain. Upon the warm green land lived the giants, moving slowly through the quiet forests and across the wide plains. We will let them remain gently in the background of the scene, the way distant animals are simply part of a calm landscape at dusk. The earth itself, its warmth, its seas, its drifting land, is the story we are following tonight. Through all the Mesozoic ages, the slow processes never paused. The continents kept drifting, the new oceans kept widening, mountains rose along the edges where plates met, and wore slowly down again. The deep, patient engine of the earth turned beneath the warm green world exactly as it always had, indifferent and unhurried. It is calming to think how long this gentle world lasted. The Mesozoic stretched across nearly 200 million years, far longer than the age that has followed it. For all that immense time, the earth was mostly warm, mostly green, mostly quiet, turning patiently under a soft sky, in no hurry whatsoever to become anything else. There is rest in a world that simply continued, warm and green and unhurried, for 200 million years. Nearly all of the Earth's history is made of such long, quiet stretches where very little changed for spans of time longer than the mind can hold. The calm ages are the rule. The turnings between them are rare. The breakup of Pangaea slowly drew the map we know. As the great rifts widened, the Atlantic opened gently between the parting lands a little wider each age, and the continents drifted toward the positions they hold today. The very shape of our coastlines, the way some seem they might fit together, is a quiet echo of that long, slow parting. Because the poles held no ice, the warmth reached gently to the ends of the earth. Quiet forests grew in the far north and far south, in lands that today lie under snow. The whole planet wore a mild green softness. From one pole to the other, perhaps the gentlest, most evenly warm world the earth has ever been. So much of the rock beneath our feet was laid down in these warm, shallow Mesozoic seas. Vast beds of pale limestone and soft chalk, built from countless tiny shells, settled quietly across drowned continents and hardened into stone. A great deal of the gentle scenery of the world today is, quietly, the floor of a calm sea that vanished long ago. And yet even the longest calm eventually meets a turning. The Mesozoic ended with one of the most famous moments in the Earth's whole history, a single quiet line written into the rock all over the world on a day 66 million years ago. Let us drift gently toward it. Around 66 million years ago, after the long, warm Mesozoic, the Earth passed through one of its most studied turnings. We will move through it gently and without fear, the way one might read calmly about a great storm that passed long ago and was followed in time by an ordinary quiet morning. On what was, in deep time, a single day, a body from space, a rock perhaps 10 kilometers across, drifting in from the dark between the planets, met the Earth. It arrived in the shallow sea near what is now the Yucatan in Mexico. After 4.5 billion years of the planet quietly gathering such bodies, one last large one arrived. The encounter left an enormous quiet crater, more than 150 kilometers across, buried now beneath later rock and sea. For a long time no one knew it was there. It was found slowly by patient people reading faint clues in the earth, a buried ring, a strange layer, a quiet anomaly in the stone. The first clue was a thin layer of clay. All around the world in rock of exactly this age, geologists kept finding the same quiet band, a fine line of clay, only centimeters thick, lying gently between the rock below and the rock above. It was the same everywhere, as if the whole earth had written a single quiet sentence at one moment. Within that thin clay was a faint trace of a metal called iridium, rare in the Earth's surface rock, but common in bodies from space. A father and son, the Alvarezes and their colleagues, slowly read this quiet clue and proposed that the line marked the arrival of something from beyond the Earth. The rock itself had recorded the day. After the encounter, the world grew quiet for a while. Fine dust and haze rose into the air and spread gently around the planet, and for a season the soft sunlight was dimmed. The warm green world cooled and stilled. It was, in the language of deep time, a brief shadow passing over a very long story. In that quiet, much of the old living world gently gave way, including the great giants of the land. We will let them pass softly, without drama, the way a long age simply ends. They had lived upon the earth for well over 100 million years, far longer than any creature since, and their long quiet age came gently to its close. And then, as always, the haze slowly cleared, the soft sunlight returned, the world warmed gently back toward life. The seas and the land, quieter now, began once more to fill. The thin clay line in the rock is not only a record of a turning, it is also the quiet place where just above it the world begins again. You can visit that line today. In quiet road cuts and sea cliffs in many countries, the thin, pale band lies exactly where it settled 66 million years ago, with one whole world in the rock beneath it and another in the rock above. It is one of the calmest, most patient pages the earth has ever kept. There is deep reassurance in that thin, quiet line. Even the most complete of the earth's turnings was followed, just above it in the very same rock, by recovery and renewal. The world has never reached a page it could not continue past. The story has always gone on gently into the layers above. The thin clay line carries more than iridium. Within it, in places, are tiny beads of once molten rock that cooled in the air and settled gently back to the ground, and grains of quartz marked by a brief intense pressure found almost nowhere else. Each is a small quiet witness, sealed in the layer, telling the same calm story in the language of stone. The buried crater itself was found patiently, not by digging but by listening to the earth. Faint, almost circular patterns in the planet's gravity and magnetism gathered slowly over years of careful surveying, traced a great ring hidden beneath younger rock and sea. The earth had quietly kept the record. It only waited for someone to read it gently. Because the clay line settled almost everywhere at once, it has become one of the Earth's most useful quiet markers, a single moment recognizable in rock around the world, a shared page that lets the whole planet's history be gently aligned. Even its greatest turning, the Earth turned into a calm tool for reading time. Above that line lies the most recent age of the Earth, the long, slow cooling that led at last to the rhythmic ice and the quiet world we know. Let us drift gently toward the final part of our story. The most recent great age of the Earth, from 66 million years ago until now, has been a long, slow, gentle cooling. After the warm green Mesozoic, the world quietly began to lose its heat, age by age, drifting toward a cooler and crisper world, the one we have been born into, near the cold end of a very long descent. The cooling was patient and uneven, but its direction held. Slowly the warm, shallow seas drew back. Slowly the polar regions chilled. Around 34 million years ago, the first great ice sheet began to gather quietly over Antarctica, and the Earth, for the first time in a very long age, again had ice at its poles. Then, within the last few million years, the world entered a long series of ice ages. Great ice sheets spread slowly down from the north across the land, rested there for ages, and then slowly withdrew again, only to return. The Earth had begun a quiet rhythm of cold and warmth, breathing ice in and out across tens of thousands of years. This rhythm is not random. It is set very gently by the Earth's own slow motions through space, small steady changes in the shape of its orbit, the tilt of its axis, and the slow wobble of that axis over thousands of years. These quiet cycles softly alter the sunlight the world receives, and the ice answers slowly in time with them. The ice has been a patient sculptor. Where the great sheets rested and moved, they slowly carved the land, rounding hills, scooping valleys, and leaving lakes and quiet ridges behind when they withdrew. A great deal of the gentle scenery of the northern world was shaped, slowly, by ice that has since melted away. We live within this rhythm now in one of its warmer pauses. The most recent great ice withdrew only about 11,500 years ago, and since then the world has been in a gentle warm interval called the Holocene, a quiet, steady, mild stretch of climate, the calm in which all of recorded human history has taken place. It is worth resting on how brief our part of this is. The whole of human history, every story ever told, every life ever lived that we have any record of, fits inside that last short, warm pause, the final thin layer at the very top of a stack of rock 4.5 billion years deep. And beneath that thin, recent layer lies the whole vast story we have traveled tonight. The gathering cloud, the world of fire, the birth of the moon, the first rain, the long age of microbes, the rising of the air, the great ice, the wandering continents, the living seas, the green land, the quiet turnings, and the gentle beginnings again. All of it is still here, held quietly in the rocks beneath every landscape. The old stone still carries its record. The continents are still drifting, a few centimeters a year. The deep, slow engine still turns. The rain still falls into the seas exactly as the first rain did 4 billion years ago in the dark. There is a deep rest in this perspective. The Earth has been patient beyond all imagining. It is passed through fire and ice and quiet and renewal, never hurrying, never failing to continue. Whatever any single night holds, it is small and safe against 4.5 billion years of a world that has always gently gone on. So let the long patience of the earth be the last thought you carry into sleep. The slow rocks, the drifting land, the falling rain, the quiet turning of a very old and very steady world that does not need you to watch it, and that will go on gently while you rest. The rhythm of the ice is recorded in quiet places for those who learn to read them. Deep in old ice, fine layers hold the trapped breath of ancient air. In the mud of the sea floor, slow sediment holds the same patient beat. From these calm archives, the long in and out of the ice ages can be read like the slow breathing of a sleeping world. We live in one of the gentle out-breaths, a warm pause called the Holocene. It has been mild and steady for some 11,000 years, a quiet, even stretch of climate, calm enough for fields and cities and long human stories to unfold. On the scale of the earth, it is the briefest of soft intervals, and we have spent all of our history within it. Hold this last thought gently as you drift. Everything you have ever known has happened in the thin, warm top of a record 4.5 billion years deep. Beneath it lie the fire and the first rain, the long microbial calm, the rising air, the great ice, the wandering land, all still there, all still quietly continuing, holding you tonight near the gentle top of an immense and patient story. Tonight, somewhere, the old rocks are keeping their record in silent canyon walls. The continents are drifting far too slowly to feel. The rain is falling into ancient seas. The deep, patient earth is doing exactly what it has done for ages beyond counting, and you may rest, now gently held within that long, quiet story. Thank you for letting us be part of your night. If this slow journey helped your body settle, subscribing is the kindest way to keep these hours coming. Each week we travel somewhere new and ancient and unhurried, always within the ancient deep time history of the earth, always meant for rest. The journey we have taken tonight, slowly through the deep history of the earth, has reached its quiet conclusion. We have traveled from a drifting cloud of dust through a world of fire, the birth of the moon, the first long rain, the patient age of microbes, the slow rising of the air, the great ice, the wandering continents, the living seas, the green land, the quiet turnings, and the gentle beginnings again. Each part of that story unfolded across spans of time so vast they can only be approached gently. There is no need to hold any of it. The dates and names can drift away. What remains is only the quiet shape of it, a very old world, becoming itself slowly, patiently, across ages beyond counting, in no hurry at all. The journey has been slow on purpose. Deep time itself moves slowly. The cooling of a molten world, the falling of the first rain, the drifting of the continents, none of it was ever in a hurry. Whatever you have followed and whatever you have drifted past, all of it is exactly right. The night has been holding the journey for you. As we close, let yourself rest. Let the bed hold you the way the deep rock holds its long record. Quietly, faithfully, without effort, let the breath continue on its own, without your supervision. The slow work of the night, like the slow work of the earth, is being done without your help. You only need to allow it. Tonight, The old rocks are still keeping their record in silent canyon walls and quiet sea cliffs all around the world. The continents are still drifting, a few centimeters a year, far too slowly to feel. The rain is still falling somewhere into the seas, exactly as the first rain fell 4 billion years ago into the dark. There is a quiet companionship in that. The deep past does not know you. The old stone cannot tell that you are resting here, aware of it, and yet here you both are on the same patient, turning planet, continuing together the long, quiet story of a world that has always gently gone on. The patience of deep time is a good patience to take into sleep. The way the molten world cooled without hurry, the way the first rain fell for ages, the way the continents drift a few centimeters a year, let some of that slow, unworried quality be present in your own gentle drift toward sleep now. There is no rush to fall asleep, and no particular moment that must be reached. Sleep arrives the way dawn arrives over an old landscape, the way new rock slowly forms, the way the continents quietly move gradually, gently, without anyone announcing it. It does not need to be summoned, it only needs to be allowed. If your eyes are still open, you may let them close now. There is nothing more to see, nothing more to learn, nothing more to remember. The rocks will keep their record whether or not anyone is watching. The continents will drift on. The night will go on deepening, quietly, all by itself. Sleep deeply now, the night will hold you. The earth will go on turning slowly, patiently, exactly as it has for 4.5 billion years. Tomorrow the old processes will still be at work, the drifting land, the falling rain, the slow deep engine, steady and unhurried, asking nothing of you at all. Until then, drift slowly, drift completely, drift into the long quiet story of the ancient earth, where the rocks rest patiently in their layers, where the continents wander too slowly to feel, and where the deep patient world continues gently on its own, whether anyone is watching or not. Let your breath grow slow and even, the way the seasons of the earth are slow and even. There is nothing to hurry toward. The continents are not hurrying. The rivers are not hurrying. The deep rock is not hurrying. You may borrow that pace now and let each breath arrive and leave in its own unhurried time. Picture, very gently, a quiet cliff of pale layered rock at dusk. Each soft band is an age of the world, laid down without hurry, one resting calmly upon the next. You do not need to count them or name them. Simply let your eyes and your mind rest on the gentle layers and let the looking itself slow you down. Imagine the first rain falling softly onto warm, dark stone 4 billion years ago in the dark, with no one to hear it. It fell for ages, patient and gentle, gathering slowly into the first quiet seas. Let that soft, endless rain be a sound in the back of your mind, calm and even, asking nothing of you at all. Imagine the warm, shallow Cambrian Sea, lit softly from above, its gentle floor quiet and alive. There is nothing to do there but drift, the way the soft early life drifted, carried by slow water under a soft sky. Let yourself drift in that warm, calm water, in your mind with no shore you need to reach. Imagine the quiet green coal forest, warm and still and humid, its tall, strange trees standing patiently in soft light. Nothing in that forest is in any hurry. It simply grows and rests and grows across millions of gentle years. Let its deep green stillness settle over you like a soft blanket drawn up in the dark. Imagine a great pale ice sheet under a soft sky, resting silently over the land, smoothing it slowly across ages. It is not cold in this imagining, only quiet, vast, white, patient, and utterly still. Let that wide, calm whiteness empty your mind gently, the way fresh snow softens and quiets a whole landscape. Imagine the pale chalk cliffs above a calm sea, built grain by grain from countless tiny shells settling softly through warm Mesozoic water. Every fine particle drifted down slowly, without hurry, across millions of years to make that quiet white stone. Let that image of slow, gentle settling be the feeling of your own body sinking softly into rest. There is nowhere you need to be. The earth has carried every creature that ever lived without any of them needing to hold on. It is carrying you now gently on its slow-turning surface through the dark and toward the morning. You can let go of all holding. The planet has the holding well in hand. If thoughts arrive, let them drift past like slow clouds over an ancient sea. You do not need to follow them. The sky has watched countless clouds pass over 4 billion years and has kept none of them. Let your mind be that calm and that spacious, and let each thought simply pass gently and be gone. Feel how solid the earth is beneath everything, the deep old rock that has held firm through fire and ice, and every quiet turning. That same patient ground is beneath you now, steady and sure, holding the bed, holding the room, holding you. There is nothing for you to support. The deep earth is doing it. The night is long, and there is room in it for you to rest as slowly as you like. Deep time is never impatient. It has no schedule and keeps no count. Borrow that ease now. Whatever pace your sleep arrives at is exactly the right pace. There is no part of this you can do wrong. Let the body grow heavy and soft, the way warm sediment settles slowly to a quiet seafloor and rests there undisturbed for ages. There is no effort in that settling. It is only a gentle giving way to stillness. Let your own weight settle in just that way now, softly, completely into the bed. And if you're still here, still listening, that is perfectly all right. There is no finish line. The old rocks keep their record whether or not anyone reads it. The continents drift whether or not anyone feels them. The story continues gently on its own, and it will hold its place for you until morning. Good night. Outside this video, the night is still going. The old rocks are still holding their record, somewhere in quiet canyon walls and sea cliffs. The continents are still drifting, a few centimeters a year too slowly to feel. The deep, patient processes that built the world, the cooling, the raining, the slow wandering of the plates, are still continuing tonight, exactly as they have for ages. Tomorrow comes when it comes. Until then, sleep deeply. Good night from the Circadian Institute.